Okay, hi.
Hi.
My name is Leona. Can you hear me like this? Or louder? Yeah, you can hear me, okay. Okay, what I want to address today is something that LaRouche put out as an initiative. He's done it before, but I think sometimes it's, well, let's just say this, he's stressed it much more recently, which is that not only do we have to go to Mars now, but that it has to be Mars. And I know just from organizing around the policy papers that we put out recently, these are still questions in people's minds. And so that's what I want to get at today. Now, I was a member of was one of the co-authors of this recent policy paper, and that's, right now the outreach on that I think is going to be very, very crucial. But now, one of the questions that comes up is, okay, right now we're dealing with existential crises. Right now we're dealing with World War III, the very, very hair-trigger possibility of Israel launching a war that would pull the United States in and basically the whole world in after that, and so on. You've got those type of crises, all the ones that Alexandra laid out, and it's very, very real. It's becoming more and more real to more and more people. And so the question comes up now, if we didn't go to Mars 10 years ago when it wasn't as much of a crisis, why would we put our efforts in now to something that doesn't seem to directly correspond to the direct crises I'm facing right now? And for those of you who go on the streets every single day and organize, you may already know the answer to this. But really, you're running into, what LaRouche laid out over the past week is that we have to take a flank on this. And specifically, we have to give people a picture that what is being discussed right now, even the things that seem relevant, or even the things that it seems like people are trying to address the economic crisis with the debt ceiling or whatever, is totally outside of reality. All of the discussion right now in the elections right now are completely outside of reality. And, I just watched this video that was excerpted at the end of this, the video you guys watched. And I was reminded that Mr. LaRouche put a full Mars program out in '88 as his presidential campaign. Right, running for president, this is what he put out. That would be that's just the contrast. The contrast is very, very stark to today. Now, so one, this gives us an opportunity to say, not what do people want to talk about, but what do we need right now? That's the standpoint that we should take it from. What do we need right now? I've had a couple opportunities to run into some very boring staffers in DC. And that's really the question. And they're not asking me that, but I know that that's their question. Because I asked them, well, where do you plan to be in 10 years? And they say, well, in a better place. And I said, dead? Where is your better place? Something better than now. That is not a good measure. That is not taking you anywhere. And this is probably why they're sitting there at their desk putting up with Obama. And so, first question I want to take up is why we have to do this right now. Why do we have to drive for Mars right now? People see that? Or we need to turn off the lights? Okay. So it could be sharp. Yeah? Should we turn off the lights then? No. Okay. All right, so for people who can't see it, this is This is a time scale from the beginning of complex life to actually where we are is, I don't know if people really have sat there and thought through where we are on this line. We actually don't appear on this line because this line is representing about 500 million years. People know how long human beings are reported to have been around, or at least hypothesized? Yeah, 2 to 10, right? That actually doesn't appear on here. Somewhere around here where the main line is. So, from experience, it's going to be very hard to tell where we are and what actually determines our actions. But through a juxtaposition of different measurements, of different data you're going to take, we can figure something out. Now, what this is here is a chart of biodiversity. So the diversity of species that existing at any one point. And you'll see a couple of characteristics. One is that it is going up, right? It shoots up, as you would expect populations to. That is very important. But two, it doesn't constantly go up, right? There are these dips. Populations of what? The numbers of species that exist. There's a couple of dramatic ones, right? Now what we did was we took that upward curve and moved it so that the general curve became a line. So you can start to look at the up and downs. Now what we see here is that throughout the period of 500 million years, there have been times where 95% of all species went extinct, just dropped off the planet. There have been times where, specifically, they call it the Great Five Great Extinctions. There have been times where entire species, several species, just disappeared. And there's different hypotheses around getting hit by things, or maybe getting covered by volcanoes, and so on. We'll see how those hypotheses play out. The key thing is that, what LaRouche says about the extinction of mankind, it's happened before. Why should we say that it wouldn't happen? But there is something a little different. One is, first of all, I don't think any species before us mapped out the extinctions of other species. Sure. So, now, it's not to say that these things will occur always, and that it's cyclical, right? A lot of pessimism right now is saying, well, it's an economic crisis, it happens, and then people realize what's happening, and then they move. You've heard that one before. These are just cyclical processes. But actually, that's totally false, and nature has proved it to us. The universe has proven it to us over as long as we have any probes to figure out. So, because what you see in this span, in this history, is that every time one of these extinctions occur, the species that become dominant, the species that are dominant through these crises, are more effective, they use more energy, they move around more, they are able to convert more material into biotic material, they're more able to transform the environment as a whole, to create oxygen, to create an atmosphere, and so on. And each time you get one of these extinctions, rather than starting anew at the bottom again, you actually start at a completely different level, higher than before, higher than any of the other species could have combined could have created. And it wasn't like any species alone said, you know what, I can't stand this anymore, I'm bored. I'm just going to create a totally new environment. And what happened is that what you actually see in these extinctions is that there is a constant drive towards a higher level of action. And LaRouche has called this the higher energy flux density, a higher application of energy for qualitatively better uses. For the species that exist on the planet to have more power in and over nature. And that when the species that existed don't correspond with that shift, they actually go extinct. They become outdated, I should say. And that this is what you're really seeing with these extinction events, is that you are just seeing a growth of the universe. In this case, right now we're just looking at the planet so far. So you're seeing a constant growth that has always existed. And when you do not correspond with that growth, you go extinct. You get an eviction notice. You are no longer useful. And that happened, the ones that we study the most are probably the dinosaurs. But before that, it's 95%. So, what I want to do is step back a little bit now, or actually step out a little bit, and look at two more examples. Now, you see that this picture, which is this funny looking name, this galaxy, this is what you see in the visible, okay? This is what you would see in a telescope, a very good telescope. Okay? This is what you see in infrared. So this part right here that you see in the visible is this little tiny part right here. See that little square right here? That's what you see. This is what you don't see with the telescope. Okay. I have a lot of examples of this, of something like this, which I can show you later. You see that the clouds here seem to be emitting out of this galaxy. That is one active galaxy. It's not dying at all. It's not winding down. I'll show you another example which we've used several times before. Crab Nebula. Similar thing, right? This is what you see in a very good telescope, in the visible. This is what you would see in the X-ray. Right? UV. Now, this object we saw was detected in 1054 AD. Not that long ago, according on the scale, if you compare it to the scale we were just looking at, very, very, very new appearance in our sky. And since then, even though this is supposed to be, according to astronomers, it's supposed to be an exploded star, it's supposed to be dying, and so on. Since then, it's done some very funny things. One is that it's expanding faster. It was increasing its speed of expansion. Two, it has created these amazingly huge bursts of gamma rays. Huge bursts of energy. don't know if you call that a death rattle or what, but it's instead of just dying off and slowly withering away and becoming nothing or becoming just gas, it's instead pumping out an incredible amount of energy. It did this several times over the past year. And these flares. And these are just a couple of examples of what you see that seem to be things that are either still or dissipating. But they're actually signs of the opposite, of extreme growth, of extreme creative processes that, and there's one I didn't include in here, that are creating stars and so on. Now, what I want to point out now is something else. Okay, so this line here, sorry it's very small, but this green line here is the one we were just looking at, the biodiversity. Okay. Now, what they saw is that these extinctions occur on the scale of 62 million years. And so they're all almost cyclical, but they occur about 60 million years. Give or take a few million years. Now, think about this. What do you know that is a process on Earth or of Earth that is on that scale? Is that the sun? What about the sun? We've got a couple of things, right, that we go around the sun. Because, this is a possibility, right? And a lot of people, especially the global warming freaks, talk about the sun having lots of influence. Now let's look at this, because we go around the sun once a year. That's how we define the year. That's our year. A little shorter time. We have the sunspot cycles, which go about 11 to 13 years. Still pretty low, right? Not 62 million years. We have the ellipticity. Sometimes our elliptical shape changes a little bit. It's about, 10 million years or so. Now that's getting pretty big already. You're talking about the change of the orbit of Earth. So now you're talking about, now you gotta ask, okay, well, if there's a cycle, and it's being influenced in some way, it's not being created from Earth, in the sense that it's upturning from inside of Earth or something, and it just emit poisonous gas every 60 million years or so. It's not coming from the sun in particular, maybe not alone, and it's not coming from any of these changes. Then what's causing it? What could express or influence a cycle on that scale? And this is where now we have to step back from ourselves and say, okay, well maybe we're just a little too localized at this point. And so there's been a couple of hypotheses. One is one that we presented several times, which is the travel through our galaxy's arms. Right? And because they've seen two different cycles, they've hypothesized both an up and down motion through the arms and a sideways motion. And this is just a hypothesis now. But they were forced to this hypothesis because what else do we have on a local scale? We have to look somewhere else, somewhere further. Now, what we mapped was a couple of other things. Is that not just the increase and decrease of the number of species, but sedimentation. So how much sediment, how much fossil soil basically is laid out. Sedimentation, seawater levels basically. Volcanic activity. Right. We've mapped out is that these things, which seem all very, very different, and you might have said that one caused the other, have a similar cycle. And same thing with our measurements of cosmic radiation from isotopes and other things. Our measurements of sea surface temperature. Huge processes of the planet. And yet, corresponding to huge cycles that correspond to each other. So they're dealing with what seems to be a process that's planetary, but is probably more. Probably not just planetary. So now what does it say? What does it say about our galaxy? If it is true that this history says that at least life is always evolving into, not just evolving into different things, but evolving into a capability to have power over the universe, right, over its environment, to be able to change things, to be able to change its environment for itself and for posterity. If that's true for life, if that's true for stars, that they are also creating more and more potential for other stars and so on. What are we asking what are we asking for in the characteristics of our galaxy? And what do we demand that the galaxy's characteristics have to be to have this type of influence or to be in the system? Not yet. I'll take questions at the end. Okay. So, this is now, we've come to a point where, right now, human species should have been much, much further than we are. Our reach should be much further than we are. People know what Kennedy's plan was for being on Mars? Nobody here? 84. I was 2 then. I could be on Mars now. Right? We had already landed a man on Mars in 84. And that's an evidence. Just put yourself in that, because it's been several decades now. A whole generation has passed. And what he said then, and that plan to be there, is not just something that you like to do. It's not something that would be great to have, and whoa, boy, wouldn't it be better to be an astronaut instead of working at McDonald's. That's not the point. That's where we should have been, and that's where we should at this point have surpassed. And that's our measure. Our measure is a point where we, as a species, should actually be right now, and where our universe actually demands us to be right now. And you saw with these processes that the natural process of the universe is towards higher and higher abilities to influence your environment. And when these species don't continue with the universe universe in that process, then they go extinct. You know, that's why, these crises that, it's funny because LaRouche talks about these galactic crises. And sometimes people say, okay, well, yes, galactic crises, but I've got this crisis, I've got war, and I've got famine, I've got disease, and so on. What are those crises created by? Why do we have those? Is not war and famine and disease, are those not unique, old world problems? When was it ever the case that we believed that we could never get rid of famine? Current technology, right? Disease. I mean, we went from 30% malaria in the United States to what we have now in, 2 decades with Roosevelt? War? Come on. Right, especially this type of war, just imperial war. I mean, empires almost dropped off the face of the earth after Lincoln. So, the problems that we face today, right, the problems that we face today are a result of our unwillingness to evolve, to do what the universe demanded of us. And you know from the results, from the history, that when we do not evolve, we do these type of things. We get evicted. We have almost got an eviction notice from the universe. So, that's why we have to go to Mars. Now, why Mars? Why specifically Mars? Why can't we go to the asteroid belt? There's so many other things. I've even heard people say, well, if you just want a science driver, if you just want people to develop, why don't you dig into the depths of the ocean? We don't know anything about that. We should have been digging in the deep depths of the ocean. But here's the question, and it was really laid out very beautifully by Mr. LaRouche in '88, which is, how do you challenge the frontiers of the frontier? And how do you encompass everything? The nanophysics, the plasma physics, the biology, your healthcare system, your fusion research. How do you take every single forefront and forefronts that we are not moving on and push them to its limits? And this is the key, is that we've got a situation where, we're beyond the point of the Lewis and Clark expedition already. Can't just, we're at the point where, Obama said this really silly thing where he says, some people want to go to the moon, but to tell you something, we've already been there. Now imagine if Lewis and Clark had said that. And so, if we're actually beyond the point right now where we can just send a manned mission to Mars and call that a victory. That's what we should have done in '84. We're beyond that already. What we have to do right now is to establish a complete space environment. What we have to just do right now is just be able to say, okay, we're going to build a colony on Mars with people, with enough people to have not only a research center there, but also all the logistical support in either the immediate environment, and either on the planet or in the immediate environment, which will mean not only a transportation network, but also midway stations, gassing stations, power beaming, for example, or power sources. That means a full capability, like for example, the way we deal with GPS, where we've mapped out almost all of the entire globe. Stretch that out. You'll have I guess you could call it SSPS, a solar system positioning system. But you will need all these things just for basic activity. You need a full environment monitoring system. In the same way that we measure position, weather, ionosphere, magnetic field, and so on. We're going to need to do that. We really should have already been doing that, but just to paint you a picture of what it means to have a full space environment. That would be what would be necessary to have a colony on Mars. Right? We have to deal with cosmic rays. Right? If cosmic rays are actually having maybe some influence on the biodiversity, and we already know that life responds in a very, very intricate way to different electromagnetic frequencies, then we have to know those things. And these are the type of things where LaRouche pointed out in '88 that you have these fields that would have to be developed: plasma physics, lasers, optical biophysics. Right? These are fields that would have to be pushed just to get this thing done. And those are the type of fields that are our forefront and would necessarily have to achieve a higher forefront in order to do this. So this may include mining the depths of the ocean. It may also include mining the asteroid belt. Not just may, it will. Right? But that's the idea, is that you need to have a driver that places humanity on a totally different platform where you cannot apply the same things. Like, for example, not that there wouldn't be new technologies created in going to mining the asteroid belt, but what are you mining the asteroid belt for? Are you going to go mine iron, bring it back to Earth, and use iron for what it does now? Is that really a new thing? Or are you just finding another mountain to climb? Now, take this for example. I'll just give you one example of a totally different economy. LaRouche calls it a fusion economy. Now, I'm not going to go through fusion right now. What I'm going to go through is how to imagine a completely different economy. And this came up recently because we were discussing a timetable for NOAA, which I'll show in a second, for building a huge water power project across the continent. We're trying to think, okay, well, how many years is it going to take? How many people? How long is it going to take to train people? What type of materials would you need? How much of the material would you need? How long would it take to build the rail? Where would we build the nuclear power plants? Would we ship them in from some other place? These are all considerations. Now consider this. Let's say that by the time that we get shovels in the ground, we've already established a base on the moon. Or are in the process of establishing a base on the moon. I'll just give you one particular example and get a picture of it. Lunar soil. Okay, it looks not much more than just rocks that you find, right? Lunar soil is very different. They cannot create a replica on Earth yet, because it is so very different in the processes that create it. Now, for example, you can say the material is silicon and iron, or some part of it, the dust. Silicon and iron, right? I'll give you a good indication that it might be a little different though. When you heat it, it does nothing. Not nothing, but you heat it a lot, then it does something. It melts. If you stick it in your house microwave, it turns to liquid. So something's different. You can't stick a rock in your microwave. You could, but it won't turn to liquid. It may turn your microwave if it had enough metals in there. So it should tell you something different. Now, we had all sorts of problems with this stuff because it looks like fine dust, like soft, fine dust. And you get it on everything, and it starts scratching through everything. It scratches through the uniforms, it scratches through their knife-proof bags, and so on. Now what happened is that they realized something about this. That you have little tiny particles that are silicon that are finely coated with iron. Very thin, fine coat, little piece. And what it's created is miniature little dielectrics, miniature little conducting pieces, each with a different amount of conductivity. Right? So that the amount of energy you would have to put in, like even microwaves, that you would have to put in for each piece to melt is different. So now that's very, very unique. We don't have that, because we haven't found that property here. Would we want to do something like this, for example? Would we want to take the dirt, melt it down into iron and silicon, and use it in building buildings? Is that the most efficient thing we can do with it? I'll just give you a funny here. This is a schematic of how to pave a road with microwaves. Right? And they even, this same paper said, look, you can take a crater, microwave it, and have a giant satellite dish. Or pick it up and make a structure out of it. I give you this example because now take this one simple, and this is not something, this is already known. And this is known for now a decade or more. So take something as simple as this. If this becomes in use, in practice, what does that mean about the construction of the Wafa? Maybe you wouldn't even use cement. You know, it's funny you're asking how much cement we need. Maybe we don't need any. Now I'm not proposing that, but just give you an example of how, for example, what LaRouche is pushing for, which is a fusion economy, right? When you've actually conquered the atomic processes, not just fission, but also fusion. How is that going to change every single thing we do? How is the immediate push for education for people to be able to operate in and around the activity of Mars colonization, how is that education going to change the capability of your workforce? As opposed to just saying, putting everybody into construction school. It completely changes your plans now. And this is really how we have to start to think about it, because it is really a major flank we're just putting out here. It really is. It's not that we have to get better. It's not that we have to feed more people. We at this point need to evolve, or we're not going to be around for much longer. That's it. We're getting a bottom line here. Right? It's expressing itself in all of these different problems. And like Alexander put out, it's when you're in the womb and there's all these little problems that you want to take care of. It's getting big, it's getting tight, it's getting a little hot in here, and you may not want to make that next step. Seems very frightening, but you have to have to evolve. Otherwise, those crises catch up with you. I think, no, whatever. We'll definitely be putting more out on this, but the last two papers, with generally the same theme, self-developing galaxy, self-developing universe. That is the idea that we're going to have to get across to people immediately, in a totally impractical way. Because practicality right now stinks. I'm going to stop there.